Hello all, welcome back. In this today's class, we will try to implement the 8 to 1 multiplexing operation, right? So what do you mean by 8 to 1? So 8 inputs, single output, right? So 8 inputs, 1, 2, 3, 4, 5, 6, 7, 8 inputs. Then how many outputs we have? Single output value. So how many selection lines are required? 8 inputs. We can write in terms of the 2 power n, right? It means 2 power 3, where 3 represent the number of selection lines. So it means that we required S0, S1, S2 are the 3 selection lines, right? So once it is done, next what we have to do? We need to draw the truth table, right? So remember that the important role will play is by the selection line, not by the input. Based on the selection line only, we are going to get the output. So 3 selection line means how many possibilities? 0, 0, 0, 0, 1, 0, 1, 0. Like that up to you will be getting the triple 1, right? So based on the selection line only, any one of the input will be routed as the output value, right? So here selection line will play the important role than your input values, right? Now next step is that we need to draw the truth table operation, right? So inputs are the 3 inputs, then output is the single outputs. The moment you select the selection line value 0, 0 means what is the decimal number 0? It means that I0, here decimal number is 0, right? So I0 will be your output value. Selection line is 0, 0, 1 means 1, right? 1 means I1 will be activated. So like 2 means I2, 3 means I3, so 7 means I7 will be activated. Once it is done, we need to find the third step is the logic expression, right? As we discussed in the previous class, right? So without using the K-map, we can find out the logic expression because it is the one of the application of the logic function generator, right? So logic function generator. So multiplexer is the application for the logic function generator, right? No K-map is required, right? So how many output expressions we have? Only single, right? So y equal to single output expression, right? So when we are getting the selection line I0 value, so I0 is being selected when input value equal to 0, 0, 0. 0 means what? S2 bar, S1 bar, S0 bar, right? So S2 bar, S1 bar, S0 bar, right? So this is one possibility. Then when you are getting the I1 value, the I1 value is getting based on the selection line, right? What is the value? 0, 0, 1, right? It means that S2 bar, S1 bar, S0 plus next I2, right? So next I2 into what is that value? S2 bar, S1, S0 bar. Next plus I3 into S2 bar, S1, S0, right? Plus, so I3 also completed. Now what is the equation? I4, right? I4 means what is that value? S2, S2, S1 bar, right? I4 means S2, S1 bar, S0 plus I5 means S2, S1 bar, S0 plus I6 into S2, S1, S0 bar plus I7 into S2, S1, S0. So this is the logic expression, right? So after finding the logic expression, what we have to do is we need to draw the logic circuit diagram. So here single output means if you see that how many inputs, this is 1, 2, something like this. If you observe here, so we have the S2, S1, S0, right? So this we will consider as the, right? So S2 bar, this one will be S2 bar. Then again we will consider this as the S1, this one is for S1 bar. So here we will be consider this as the, right? So something S0, this one will be S0 bar, right? Now what is the first product term? I0 into, so like this we will consider, right? So it means that this is the I0 value. So I0 into S2 bar, S1 bar, S0, right? So S2 bar, next S1 bar, next S0 bar. Which logic gate it is? AND gate operation. What is the next one? I1 into, so I am taking external connection wire, I1 into S2 bar, then one more is the S1 bar, then one more is the S0, right? This value is S0, right? S0. So which logic gate? AND gate. So like that we have to draw, then find out what is the final one. So just I am not going to explain here for remaining things. You just try to complete this remaining process. Finally what is that? I7, right? So let we take I7. Here you need to take I2, I3, I4, I5, I6. I7 into something like this. I7 into what is that value? S2, S1, S0, right? So S2, next S1, one more is the S0, right? Again which logic gate? AND gate, right? So finally we are going to perform the OR logic operation, right? So this is how we are going to design the 8 to 1 multiplexing operation, right? I hope you understand, right? Here remember that I didn't wrote for I2, I3, I4. You just complete same way, I1, sorry, I0, I1, something I2, I3 up to I6, I7, then you connect it to the OR gate operation, right? Thank you.